Within the 16.1 TOTECS platform release, we've had additional capabilities for website hosted on the platform by companies to have emails sent out on behalf of those companies and to ensure that those emails are not marked as spam when they are received by recipients and the recipient mail servers. TOTECS can do this by utilizing the domain keys identified mail, also known as DKIM, which allows additional data to be included with the email to verify TOTECS is a legitimate sender. This removes the need to rely upon additional third-party email providers and allows emails to be identified as coming from a safe sender for any kinds of email domains that are being utilized for a TOTECS hosted website. Before I show you the details on how to set up the functionality within the TOTECS platform, it's important to understand how the underlying authentication mechanisms work for email and the DKIM authentication processes. If you already understand that, then you can skip ahead to this video. Otherwise, I'll give you a brief background on how this all works. So within the TOTECS platform, websites can be hosted on that. And then when there's certain things happen in a website, such as a user submits an order or some e-marketing emails need to be sent out, an email will be created that needs to be sent out. Now that email will be sent out behalf of the company who owns the website. We have example.org.com, and they want to send out a notification from their notify email address here. So when this occurs, an email first gets generated and sent out from the TOTECS platform servers. That goes through what we call an outgoing email server, and then that goes through the general internet and it gets received by the recipient's incoming mail server. So in this case, we have recipient at eg-email.com. So eg-email.com would have an incoming mail server that listens for emails on that domain, and then that will get passed across to the inbox or the email client containing the email inbox for that recipient. As you can see here, if anybody can pretend to send emails out on behalf of example.com, then that can pose a problem for the incoming mail servers and the email clients, because then that allows lots of emails to get thrown across the internet. And if they're not coming from legitimate senders, then the recipients are unsure which emails are legitimate and which emails are not. Now, incoming mail servers have put in additional protection mechanisms to try to weed out the bad actors who are sending emails from the good actors. So a company needs to have a way of deciding which third-party platforms are allowed to send out emails from their email domain. And the one way to do that is this authentication system that has been built into email called the Domain Keys Identified Mail, or DKIM for short. This uses a range of technologies that already exist in the internet in order to do the validation and checks that need to happen. So one of those systems that is used is the domain name server functionality across the entire internet. And if you're unsure what this is, basically, there are computers that exist in the world where the records for each website domain is stored, and those servers tell all the other computers that are connected to the internet where the website is hosted for a given domain. So example.org.com may have a record stored on a DNS server that then points to the TOTECS platform servers for where the website can be found. So the DNS system is equivalent of a phone directory that you'd previously use to find a person and then find the phone number of how you can call them. So one of the things that the DKIM authentication processes used is the domain name server, and these servers can be also used to allow other pieces of information to be shared. And one of those pieces of information are these things called cryptographic keys. We can use these, what they call key pairs, a private key and a public key, in order to perform authentication on the emails. So the way that this works is that a public key is stored on the domain name server, and that's a key that any computer across the internet can freely download and get access to. And there's a corresponding key that is paired to that called the private key that should only be granted to systems and software that are allowed to send emails for a given website domain. In our example, the example-org.com website is hosted on the TOTECS platform, and email needs to be sent out from that domain. And what can happen now is when the email is generated, the private key the TOTECS platform holds can then be used to sign the email. So the private key signs the email, and then a signature is generated from that private key, and then both the signature and the email is passed through the outgoing mail servers to the incoming mail servers and mail clients containing the signature. Those incoming mail servers can do is they can then ask for the public key which is stored in the domain name server. They can copy that back to their own computer and they can check to see if it pairs up with the signature that is attached to the email. If the signature matches the public key, the incoming mail server knows that the email came from a legit sender that is allowed to send emails on behalf of a given domain name. This is where we get the name of the domain keys identified mails. We're talking about the cryptographic keys that are stored within the DNS system against a DNS record, as well as on each of the servers that are allowed to sign the emails and send on behalf of an organization. So if that all works out, the email can then go to the recipient and it won't flag the email as being spam because it knows it came from a trusted sender. So in this case, the TOTECS platform would be the trusted sender because it has the private key. Now let's say if we had a bad actor who also had their own private key that they were signing the email with. When that got sent to the incoming mail server of the recipient, the incoming mail server will be able to check if the signature matches up with the key. In this case, because it's an incorrect signature, they don't match up. And what would happen is that the incoming mail server would go, nope, that's from an illegitimate sender. So that email should either be discarded or it should be marked as spam and put into a spam box. And the same checks can also be done in the email client software as well. This also highlights where there are potential vulnerabilities. If the bad actor got their hands on the private key, then they could then sign the emails and they could get it through the incoming mail servers and not marked as spam or as coming from an illegitimate sender. So the private key, as the name intends, should be very private, should only be passed across to trusted sources that are sending emails on behalf of an organization. And the same is true as well. If the bad actor could change the public key that is stored on the domain name server, then that also would be a security vulnerability. So now you can see the limitations of this system and also where its strengths are, utilizing standard components of the internet in order to do this validation. So this is just one mechanism that certain incoming mail servers or email clients may use to determine whether or not an email is spam. For any websites hosted on the TOTECS platform, putting these DKIM keys is a great step in order to help guide the recipients so that there's greater chances of these emails not being marked as spam. So now that you have an overall idea of how the DKIM authentication works, let's see how we can set that up in the TOTECS platform now. So the first step we have to do is we need to generate the public and private cryptographic keys for the DKIM authentication. Now the easiest way to do that is to use a piece of software called OpenSSL, which is both a library and can be used as a console application within any operating system. Now, if you're using Linux, OpenSSL may be already installed in your operating system, but if you're using Windows or another flavor, you may need to download from the choice of different OpenSSL Windows clients. And OpenSSL in this wiki page provides links to the different pieces of software you can do that. Once OpenSSL is installed on your computer, can be accessed if we opened up a command prompt. And we first also want to create a folder where we want these keys to be generated and stored in. So I've created one in my C drive under the temp folder, and I've created a folder called DKIM-keys. So in our command prompt, if I go to that directory, so if I then run this command, it's going to call the OpenSSL program. It is going to generate a private cryptographic key, and it's going to be a size of 2048. So we click out the enter key. Now, if we look in that directory, we have a folder called private.keys. Now, if we run the next command, it's going to generate the corresponding public cryptographic key. So this command is calling OpenSSL. It's going to read in that private.key file and it's going to generate a public.key file. So if we run that command, you can now see in our directory, we now have public and private.key. So these are the two keys that we require. Now, a third command needs to be run. And what this is going to do is going to save the private key into the PKCS8 format. And that's what we need specifically for TOTECS to be able to save the private key within a project on the TOTECS platform. So we'll click the enter key. So now then we've got these three files that are stored in our directory, and you can open and view these files because they are just text files. So here's what they look like. These are cryptographic keys, so it's a jumble of letters and numbers, slashes and other characters. You can always see which key is private or public because we have these wrapping headers and footers to denote if they're public or private. So what we need to do now is create a DNS record against the website domain where we want this public key to be stored, and we need to get the private key put into the TOTECS platform. Now, when we create a DNS record containing the public key, the DNS record needs to have the value as shown above. So it's going to have a text string that contains what the version of the DKIM the record supports, and it's going to say what the cryptographic cipher is being used, and after that is all the key information. So what we have to do is, back in our public key file, we need to strip out any of the header and footer information, and we can also get rid of all the new line characters. So now we've got our key that is in just a single line of text. So we would put that into our DNS record string. So that goes anywhere after this p equals attributes. Now we need to go into the server that is hosting our DNS record for our website and create a DNS record. Now this changes depending on which DNS provider you are using to host your DNS records for your website. But there are some commonalities that need to be set. Firstly, this record needs to be created under the correct domain. If our domain was example-org.com, then we need to create a record that has the word _domain key. And before that, it needs to have the word default. So it's default._domain-key.example-org.com. So default is what we call the selector. Its parent domain is then identifies this as being a domain key based domain to do validation against top level domain. Now this is the default way to do this. You can change the selectors, but it's recommended not to do that unless you know what you're doing. Within our DNS hosting provider of our website domain, we have to set up this subdomains, and then we have to create a text DNS record. We'll have the value which is shown here containing the key. So here's an example where within the DNS Made Easy DNS hosting provider, we've set up our example-org.com domain, and it's with here we're under the text record section where we need to create a text record, and within that text DNS record, that's where we put in the subdomain for our domain keys, such as here we've got default._domain key, and in that value which I was showing before containing the public DKIM key as well as the cryptographic information that is stored in the record. So it's super important that this is a text-based record that is created for the DNS provider that is storing your domain. Now you can optionally create another text record, and this provides more additional information that if the incoming mail servers need to report back information, that they can find a place, the email address where that is most appropriate to do so. And you can see that's under the domain key subdomain as well. Now with that done, we can now go into our TOTECS project to store the private DKIM key. So within the TOTECS hosted website, if we now log into the administration center, within the administration center, click on the stores menu button and then click on the general settings menu item. If we scroll down to the bottom of the page, there is a new section called email sending. And this is where we can specify who is the sending email address. Now that may be different from the from address. So the sender email address is what the email address internally to the receiving mail servers can see, such as we've got here. The sender email address may be notifications@example-org.com, but the from address may be shown as sales@example-org.com. So it's an internal identifier, the sender email address. But what is more important here is that we need to specify the DKIM domain. And the DKIM domain tells the recipient incoming mail servers and clients which DNS record they should look up in order to find the public key. If we look at our previous example, we used the default as the selector, so we will continue to use that, and then we have the @example.com, since that's going to be the domain that hosts that specific selector. If you have multiple different DKIM keys you want to use, then you would change these selectors to have different names, and this is how that is where you change those values. So we'll leave it as default. In the last field here, this is where we need to copy in the private key that was stored in the private.pem file that we generated at the beginning through the command line. We just simply copy the entire text as shown here and paste it into this field. Once done, we now click the save button. And with those settings now saved, now from any emails that are generated for the project that are non-marketing based emails, they will then use this private key to sign those emails and contain this DKIM information within it, as well as the sender email address, and that will be passed with the email contents across through the internet to the incoming mail servers and email clients to then be able to validate against. It's also important to note that if you have set the domain name within these settings here for the DKIM, that for all other project settings that reference email addresses, you also need to make sure that they are using the same domain. So if we go back to the top here, we've got a setting that determines where the order submission and registration emails are being sent to, so that should also have the same domain. As to under the accounting tab, as well as within the organization tab, within these three settings here for the payments and accounts, the feedback and inquiries, and the administration email settings. Now for marketing based emails, we also have the ability to set the DKIM details there as well. So if we click on the marketing menu button and go into e-media messaging, and we click the add button to create a new email, within the configure email message dialog, you can see that there are the same settings that are available here. So we would also have to copy the same information if we were using the same website domain within these fields here, just as I have done here. And the reason why we're doing this is because in each e-marketing e-media email, you may want to send out an email on a different domain which is different from the default of the project. So rather than sending out it from example.org, we may have it example2-org.com. So if that is the case, then a separate set of DKIM keys need to be generated, and they need to be stored against the e-media emails here. And so that means you can then manage emails from multiple website domains within the e-media messaging feature that we have. So you don't need to create new private keys and public keys for every separate e-media email. So you could, in effect, you could have 5 different website domains that you're using, that you're sending emails on behalf of, and then you would have 5 sets of private and public keys that are stored here within the e-media email message configurations, and then reuse them every time an email goes out on that same domain. So with those credentials now set, if we now then send out an email, we can then test to see if our DKIM credentials are passing the verification checks that an incoming mail server puts on the emails. So one of the best places where you can see that in action is if you send emails to a Gmail account, because Google's Gmail feature will tell you within the contents of the email when you view that whether or not it passed the DKIM checks. So for the e-marketing e-media, we could then send out our new email here once we've configured it. Then we send it to an email account that is hosted by Gmail, changing the example with a legitimate email address hosted by Gmail. Once that has been sent out, then if we log into Gmail and click on the email that is received, if we click on the More button here, click on the Show Original, within the original message, it will display whether or not that email had passed Google's DKIM checks by putting the word pass or fail, and then the domain that it did the checks on. It has passed Google's checks, and that means Google has a greater chance of marking this as not being spam, and it will go instead into the inbox or another folder which is most applicable. Note that it could still go into a separate promotional folder. Google has multiple filters for a given email account. Now, if it doesn't say pass and instead it said fails, that would indicate that there is something wrong. Either the public key stored within the DNS record is not there, such as the text record is not created or is incorrect, is not correctly formatted, or the sender of the email address has the incorrect private key, or the private key is missing, or the incorrect domain for the DKIM has been set. So there's a few things that could fail. Also note that we can view the underlying data that was stored in the email itself, but if we keep scrolling down And one of the sections that will display here is the DKIM signature, which is included in the email. So that shows you the information that the TOTECS platform would be embedding within the email when it's sending it out through its outgoing mail servers. And then we can have a look at that to see if the information within that is correct. And if it's not, such as if it's missing the signature, then it's telling us there's a problem with the private keys there as well. Now, other email clients also provide this information, such as Thunderbird. I believe it also does its own DKIM checks and does reports on them as well. This shows you the full example of how we can use the DKIM authentication mechanisms built into the email client software and incoming mail servers in order to validate and allow companies to nominate other platforms such as the TOTECS platform to send emails within the from address, and allowing those incoming servers to validate that that did come from an authentic sender who's allowed to send emails from that domain, reduce the chances of those emails being marked as spam or coming from illegitimate senders. Ultimately, this all helps the recipients of emails know that they're getting emails from trusted sources. Click on the video links to view the next features that were added to this release.